So let's talk about the idea of limit. So I've got the first question, which is saying which of the following statement about the function y is equal to f of x graphed here are true and which one are false. So we have our graph. As we can see, this is our graph. Now when it comes for limit, what we have to understand here is if they say limit as x approaches that number from the left side, meaning that let's say that number is 2. Okay, so if that number is 2, you are coming from the left going toward 2. Okay, so coming from this point going toward 2, what is the value of y? Now the value of y in this case, we are following the red line. We have 2, we have this line and this line. Okay, so now we want to see, like the first question here is saying limit as x approaches 1 from the right side is equal to 1. Is this statement true or false? If we check here, if we start from the light going toward 1, so starting from the light as we approach 1, what is the value of y? We can clearly see that we have got lead line here. This is the lead line we should have, so we have to follow that lead line. Now this lead line is sitting on y is equal to 0. Okay, meaning that as we are approaching 1 from the right side, from this side, as we are approaching 1, the value of y, we can clearly see that that line is sitting on 0, so the value of y has to be 0. So this statement is false. Okay, now we have part b, which is saying limit as x approaches 0 from the left side is equal to 0. Now as x approaches 0 from the left side, this is the left side, as we are approaching 0, what is the value of y? We can clearly see that as we are getting closer to 0, the value of y here, I can clearly see that this is 0. So this statement is true. Now if I go to b, this was supposed to be, is supposed to be x approaches 0 from the right side and not left side. That was just a mistake. Now as x approaches 0 from the right side, let's see, is the answer 1? So we are coming from now this point here. Okay, we are coming here as we are approaching 0. Okay, the answer is becoming 0 because we can clearly see that this line is sitting on 0 here as we are coming closer to 0 here, meaning that the y value has to be 0. So this statement is false. Okay, now the question here, another one, d, is saying limit as x approaches 0 from the left side is equal to limit as x approaches 0 from the right side. This is true because we said that limit as x approaches 0 from the left side, as we are getting closer to 0, the value of y is also 0. Then here if I start from the right side, it's the same, it's going to give me 0. So this statement is true. Okay, so now if this statement is true, then this is going to be true as well, because limit as x approaches 0, for us to conclude that this limit exists, meaning that limit as x approaches 0 from the left side of f of x has to be equal to limit as x approaches 0 from the right side of f of x, from the left side, sorry, from the right and left. So if this is equal to that, then the limit exists. Okay, now we can clearly see that we are saying that part d is true, because limit as x approaches 0 from the left side is equal to limit as x approaches 0 from the right side. So from the left and right they're the same, then the limit exists. So this is true. Then here is saying that limit as x approaches 0 is equal to 0. We have already solved this. It's also true. We have found 0. Okay. What of limit as x approaches 0 is equal to 1? This is false because it has to be 0. Then we go here, limit as x approaches 1 is equal to 1. Now this one it's just saying limit as x approaches 1, so we have to do both sides. Okay, so limit as x approaches 1, let's say from the left right side. So as x is approaching 1, what is the value of y? As we are getting closer to 1, we can clearly see that the red line is sitting on 0. So this has to be, the f of x has to be 0 from the right side. Now from the left side, let's see, as we are approaching, so this limit, as we are approaching 1 from the right side now, from the left side, sorry, as we are approaching 1 from the left side, we can clearly see that the value of y is going to be there. Okay, it's going to be somewhere there 1. Okay, now here it is just general, limit as x approaches 1 is equal to 1. No, this is false, because as we are getting closer to 1 from the right side, we are getting 0. Then as we are getting closer to 1 from the left side, we are getting 1. So this is false. The answer has to be the same. At the same time, this limit doesn't exist. Okay, so if this is false, then this one is saying limit as x approaches 1 from the limit as x approaches 1 is equal to 0. This is also false, because from the right side we are getting 1. Then from the right side, from the right side we are getting 0. From the right side going in this direction, we are getting 0, because this red line is sitting on 0. Then from the left side we are getting 1, because somewhere here we have 1. Okay, so that is also false. Now, does this limit exist? Let's see. The limit as x approaches 1 from the left side. So as we are approaching 1 from the left side, they are saying that it doesn't exist. So as we are approaching 1 from the left side, so as we are getting closer to 1, what is the value of y? Now we can clearly see that this limit, as it is approaching 1 from the left side, we are going to have, this is an open circle though, so we're going to have 1. Okay, but if I get it from the left side, it's going to be 0. Okay, so left and right, we need to get the same answer. So limit as x approaches 1 from the left side, yeah, it doesn't exist. That's true. Okay, what of 2 from the left side? So 2 from the left side, I can see here to say I have got the red line here. So as we are getting closer to 2, the value of y is going to be 2 from the right side. As we are getting closer to 2 from the left side, the value of y is also 2. Sorry, it's 0, not 2, because this was supposed to be also 0, because I can clearly see that the red line is sitting on 0. So this is going to be true, this is going to be true. That is it for this one. Now let me just tell you something. I want to explain something. When it comes for limit, for us to conclude that this limit exists, if we have something like this, what it means there is that if this is our destination, if someone is coming from the left going there, and someone is coming from the right going there, now it doesn't matter the load this guy is going to use and also that guy is going to use. But what we have to understand here is that as long as we're going to reach at the same destination, then that limit exists. Okay, that's the basic idea behind limits. For a limit to exist, the limit as x approaches that number from the left side and the limit as x approaches that number from the right side has to be the same. Okay, then that limit exists. Definitely that limit exists. Okay, our question 2 is saying which of the following statement about the function y is equal to f of x graphed here are true and which one are false. It's the same question, similar to question 1, so we're going to be using the same idea. Now what is happening here is we have the first question. They're saying limit as x approaches 1 from the right side is equal to 1. Let's see. So from our graph now we have two laid lines. We have this guy, but at that point is open, but this one is closed. Then we have that one, it's jumping. We also have a point there. Then you have there. Okay, let's see. Limit as x approaches 1 from the right side is equal to 1. Let's see. As we are getting closer to 1 from the right side is the value of y1. So from this point, as we are getting closer to 1, the y value is indeed 1. So this is true. What else? Another one is part B. Limit as x approaches 2 is equal to 2. So limit as x approaches 2 is equal to 2. Now as we are getting, so this one we're going to do limit as x approaches 2 from the left side and from the right side. So as we are getting closer to 2, okay, as we are getting closer to 2, what's the value of y? We can clearly see we have got a dot here. That dot is included, so it's 2. This is 1, this is 2. It's true. Again, if I come from the right side, as we are getting closer to 2, we come up with the same 2. So this is true. Okay, so this is also true. Limit as x approaches 1 from the left side is equal to 2. So as we are approaching 1 from the left side is equal to 2. So as we are getting closer to 1 here from the left side, the answer is 2. No, as we are getting closer to 1, the answer is 1. So this is false. Now as we are getting, D is saying limit as x approaches 1 from the right side is equal to 1. Yes, this is true. So they repeated this question because this and this question is the same. So again, this will be true. Okay, then x approaches negative 1 from the left side is equal to 0. As we are approaching 1, negative 1 from the left side, as we are approaching negative 1 from the left side, the answer is 0. So as we are approaching negative 1 from the left side, the answer is here, it's 1. So this is false. Then they are saying limit as x approaches 2 does not exist. It exists because part B we said that is true. Limit as x approaches 2 is true. From the left and right we are getting the same answer. So this is false. It's supposed to be true. And then limit as x approaches 1 does not exist. Let's see. As we are getting closer to 1 from the left side, the value of y is 1. From the right side, the value of 1 is 1. We can clearly see here. So does not exist. This is also false. It exists. Then limit as x approaches 3 from the right side does not exist. Let's see. So as we are getting closer to 3 from the right side, the value of y is 1. So again, this is false. It exists. We can clearly see there. Now I is saying limit as x approaches 3 from the right side does not exist. This should be also, this is the same question. So this is also false. They just repeated this. Limit as x approaches c of f of x exists at every c in the open interval negative 1, comma 1. Negative 1, comma 1. This is negative 1. Then comma 1 is here. What they are trying to tell us is, let me just draw this. From this point, we have this, and then we have that. They are saying that if you pick any point from this point all the way to that point, this limit is going to exist. Okay, yeah, it's true because this is closed. there is, unless if we had something like this, okay, like that, then we can say it is not it is not true. But here we can clearly see that it is just closed from this point going all the way there. So I can pick any point. This limit is going to be, this limit is going to exist at that point, and that's the fact. I can pick any point, this limit is going to exist. But if I had gaps here, then I would have said this is false, because if I get a point where there's a gap here, then it's not going to be it's not going to exist at that point. Okay, so this point here is true, it's going to exist at any point which I'm going to pick. Then here part K is saying limit as x approaches c of f of x exists at every c in the open interval 1 comma 3. Now 1 comma 3 is this point all the way to there, and it is closed. Now if I can pick any point there, do you think that the limit is going to exist? Yes, it's going to exist. Now it's going to exist because here I have got a point, an open one, as we can see, but I've got a dot here. So even if I pick any point from 1 all the way to 3, the limit is going to exist because at this open still I have got a dot there which is 2. Okay, so it's going to exist. So that is it for part 2. So now let's go to question 3, which is saying let f of x is equal to, this is a piecewise function, then find the limit as x approaches 2 from the right side and limit as x approaches 2 from the left side. This is right, this is left. Now when you are trying to find limit as x approaches 2 from the right side using piecewise function, we normally get a function which is greater than or equal to that number. It can be greater than or just equal to that number. Okay, so now in this case I can clearly see that I've got 2. This is x less than 2, meaning I'm talking about 2 from the left side, as we are approaching 2 from the left side. Okay, but this is saying x is greater than 2 from the right side. So I'm going to get this function because limit as x approaches 2 from the right side, I'm going to get x is greater than 2. So I'll say limit as x approaches 2 from the right side, the function is x divided by 2 plus 1. We plug in the values, 2 divided by 2 plus 1. 2 divided by 2 is 1. So 1 plus 1 is 2. So limit as x approaches 2 from the right side is 2. Then limit as x approaches 2 from the left side. Now I need to get a number less than 2 because I'm approaching 2 from the left side. So that number has to be less than 2. So I'll get the first one, which is 3 minus x. Now plugging in the value, I'll get 1. Now we can clearly say that I can even tell you something here. If you want to conclude whether the limit exists, if the limit as x approaches, like in this case we have got 2 and 2, if you plug in 2 here, you plug in 2 there, if you're getting the same answer, then the limit exists. Now part B is saying, does limit as x approaches 2 of f of x exist? If so, what is it? If not, why not? So now limit as x approaches 2 from the left side is not equal to, so I'll say this limit doesn't exist because the limit as x approaches 2 from the right side is not equal to the limit as x approaches 2 from the left side. So it doesn't exist because lim as x approaches 2 from the left side of f of x is not equal to lim as x approaches 2 from the right side of f of x. So this limit doesn't exist. Unless if these two were the same, then you would have concluded to say the limit exists. So that is part 3. So question 4 is saying we have got a piecewise function which is 3 minus x for a condition x has to be less than 2, then x is equal to 2, Then the other one is saying when x is equal to 2, the value of y is 2. Then x over 2 when x is greater than 2. Then find the limit as x approaches 2 from the right side. So we get a function, a function which is greater than 2, meaning it's the first one, or the last one, sorry. So it is x over 2, 2 over 2, 1. Then lim as x approaches 2 from the right side, from the left side, I'll get the first one. So 3 minus 2. 3 minus 2 is 1. Now the limit as x approaches 2 from the left side is equal to the limit as x approaches 2 from the right side. Therefore the limit exists. Now they are saying that and find f of 2. So when x is exact 2, the value of y is 2. Okay, so when x is exact 2, the value of y is 2. Does the limit x approaches 2 exist? If so, what is it? If not, why not? So it exists because lim as x approaches 2 from the right side of f of x is equal to lim as x approaches 2 from the right side or from the left side of f of x. So it exists because the left-sided limit is equal to the right-sided limit. So we have question 5. Sketch the graph of the following given function and answer the questions that follows. What are the domain and range of f? At what point C, that is part B, if any, does limit exist? At what point does only left-hand sided limit exist? At what point does only the right hand limit exist? So we have the last question, which is evaluate the following limits.